Hi guys, welcome to this video. In this video, we will have a look at some basic concept of vectors. First, we will have a look at the definition of vectors. Then we will move on to the properties of vectors. This will include the length, the unique vector, and also the algebra rules of vectors. And finally, we will have a look at the dot product. So the first topic is the definition of vectors. The definition of vectors is defined to be a quantity that has both direction and length. Here are some examples of vectors, like temperature, speed of a car, or acceleration. There are basically two ways to represent a vector. For example, vector AB is equal to AI plus BJ plus CK. This is called the component form of a vector. Another way is to use the position of vector AB. So we just simply put ABC to represent vector AB. Now let's move on to the properties of vectors. The properties of vectors include the length, unit vector, and algebra rules. In this case, the position of AB is ABC. So to find its length, we just simply find the root of a squared plus b squared plus c squared. And the unit vector of AB is a vector that has the same direction of AB, and it has the length of 1. So to find the unit vector of AB, we just divide AB by its length. So the position of AB is ABC, so the unit vector of AB is ABC divided by the root of a squared plus b squared plus c squared. Now let's move on to the algebra rules of vectors. The algebra rules of vectors are actually very similar to the rules of the real numbers. Vectors are commutative. This means vector A plus vector B is equal to vector B plus vector A. Vectors are also associative, so A plus B plus C is equal to A plus B plus C. And if you multiply two vectors by a real number k, then this real number k can be distributed to both vector A and vector B. And if you multiply any vector A with a 0 vector, then the result will be just 0. Vector 0 plus any vector A would be vector A. Now let's have a look at the dot product. Dot product of AB is defined to be the length of A multiply the length of B multiply the cosine function of the angle between A and B. So for example, this is vector A and this is vector B. This is the angle theta between A and B. Then we can easily find the angle between A and B because cosine theta is equal to A dot B divided by the length of A divided by the length of B. This formula is just is from this formula. So if we know vector A and vector b, then we can easily find the angle between them because theta is just equal to the inverse of this cosine function. Now, we can apply the position vector of AB to this dot product. For example, vector A is A1, B1, C1, and vector B is A2, B2, and C2. Then A dot B is just A1 times A2 plus B1 times B2 plus C1 times C2.